Okay, so we're recording page 2 of the 7.4 notes. And here we're doing some practice on separating variables by dividing or multiplying by whatever expression is in terms of y, or f of y. So for example, for this one here, obviously we can call this f of y. So if I separate it out, I'm going to multiply both sides by y and multiply both sides by dx. And there you go. It's y times dy equals x times dx. So I just multiplied both sides. Actually, I cross multiplied, really. That's what I did. That's what I did for part A. I just cross multiplied. Now in this case here, let me change colors for a bit of contrast. I'm going to divide both sides. Well, first of all, let's multiply both sides by dx. And then divide both sides by negative cosine squared y. So you have dy over negative cosine squared y. Equals dx. And also, if you like, we could convert that to secant, if you like. Make it negative secant squared y dy. Probably be easier because I know the antiderivative of that's tangent. So that would be, I think, a good idea. Here, you could multiply both sides by, I mean, you could cross multiply, I suppose, but what if we multiply both sides by dx first? Actually, let's change colors again. Let's go blue. So I suppose, yeah, let's multiply both sides by dx. I mean, we're doing that anyway in the previous two examples. So therefore, dy equals negative 3y over root x times dx. Then I would divide both sides by y, or multiply both sides by 1 over y. And so then you see how those y's go away. So it's dy over y equals negative 3 over root x dx. Again, we're just kind of practicing this stuff here. Note you could, the negative 3, if you wanted to, we could have done this. And then those would cancel here, and then you have negative 3 here, and then that would just go away, and that would just be 1 over root x. I would not do that. Sorry. So that's a note here. We could have done, we could have divided. Let me clear my screen. But it's not a good strategy. And the reason why is that, remember, you want to isolate y after integration. And that just makes it more challenging if you have that negative 3, it tags along with the y. So really, we'll just move y over to that side. That's what I do. Unless if it's like cubed or something, of course, keep it cubed. Like in the case of this one here. For d, I would just cross multiply. If you cross multiply, but I wouldn't move the x squared over though. So I do y cubed times dy equals negative 4 over x squared times dx. So dx joins the right side, and only the y cube joins the left side. So that would make it easier to do the integration afterwards. Here, it looks kind of weird, but you can actually do this. I think this is y plus 5 over 1. So you could do dy over y plus 5 just equals dx. And then when you have 1 over y plus 5, you can do a natural log when you integrate it. For f is not separable. So sometimes you do run into some differential equations where they're not separable. That would require a different kind of technique, which again, as I've dust off my college textbooks, relearned that and I forgot how to do that stuff. But in that case, you can't really do this technique of separating because you don't have x times y, you have x plus y. The bottom line, as you see down below, to be able to separate variables, you must have dy dx equal a product of f of y and g of x or a quotient of f of y and g of x. And if you just have y by itself, that's fine. Just move it over. Or if x by itself, then cool, move the dx over. Not a big deal. Another thing to keep in mind too, the solution to the differential equation, so obviously it has to satisfy the differential equation initial condition. So like what we got earlier for this one, actually let's go back over here because I don't think I checked my work for that one. Remember we had 3 over 4 minus x cubed. That's what y had equaled. So then dy over dx, if I were to work that out, well, first off, that's 3 times, don't write this down, I'm just kind of just checking my work. But if I did draw that, it'd be negative 3 4 minus x cubed raised to the negative 2 power, and doing a chain rule, negative 3x squared. So you would actually then have 9x squared over 4 minus x cubed squared. It does look a little weird, but what you could do, if you get a little creative, is you could actually pull out the x squared, and then you would have this, right? Which actually would be this. 3 over 4 minus x cubed, and the whole thing being squared. Well, didn't y equal 3 over 4 minus x cubed? So you get back to x squared, y squared. So we know that this would work. So you have to guarantee that we do we solve differential equations, solve for y, we isolate y. If you take a derivative, you get back to your original differential equation. That's what's meant by it must satisfy the given, your solution must satisfy the given differential equation in the initial condition. And initial condition meaning if I plug in 1 for x, 1 for y into this right here, yeah, if I plug 1 for x, y is 1. So that's what's meant by that condition, just so you know. If you were to check your work that you want to get back to the original differential equation. The second statement, you got to guarantee that what you get is a differential function, meaning that the derivative will be defined at whatever domain you have, and it's continuous on some interval, and contains initial x. So it means that we have to be mindful about our domains when we're doing these problems here. And that we do pick, and if there's a plus or minus when solving for y, that we don't put plus or minus. Because if y equals plus or minus something, like let's say y equals plus minus root x, let's say, then you have this, right? Positive root x and negative root x. And that would fail the vertical line test. You might remember that, right? When the vertical line crosses the graph more than once, that's not good. And so we can't have a plus or minus in our answer. That means we would have to choose which one it is. And you choose based upon your initial condition. We're going to see that in action in example 3 coming up. And again, you got to make sure that it's differentiable and continuous, all that fun stuff. So let's try example 3 and 4. Then we'll do, looks like example 3. Is that the whole page? Yeah, example 4 is done over 2 pages actually. And then we'll do a worksheet after that. So for example 3, let's work this bad boy out. So let's separate. So you have dy over y equals 3x squared dx. So that's s. That's separate. Check. I've separate now. I move the y to the left side, move the dx to the right side. We're good. Next step is to integrate. So remember, you put little integral symbols. Where we got 1 over y times dy and 3x squared dx. Well, if you integrate, that's not so bad. That's natural log of absolute value of y equals 3x cubed over 3 plus c, which actually can be cleaned up a tad. X cubed plus c. Okay. Check. We've integrated. Next step is to substitute. Substitute your initial values. So natural log of 4, or absolute negative 4, equals 0 cubed plus c. So c is natural log of 4. Check. Check that one off. That's going to be most of your points on the AP for this kind of problem. Once you've done that, you've got most of the points, just so you know. Now, then we got to solve for y, right? And I did put plus c in right away. I did do that after I integrated, so I made sure I followed through on that. Okay, then you got to isolate. You got to isolate y, right? So let's do that. If you have natural log of the absolute value of y, you got to keep the absolute value there. It doesn't just vanish. You have x cubed plus natural log of 4. This one's kind of a doozy because you do have to know your logs pretty well. Now remember, ln is log base e. I know, right? It's kind of crazy. So it means the absolute value of y equals e raised to all that junk. Which means you're going to have to do a little separation here. It's going to be, I think, if I'm not mistaken, ex cubed times e ln 4. That's the same thing. You could break apart the powers that way. E ln 4 is actually 4. Remember, e and ln's cancel out because they're the same base. So in case you guys forgot, whenever this happens, it's almost like these cancel out and you just get 4. So that's what y equals, absolute y. So y either equals positive 4 ex cubed or y equals negative 4 ex cubed. It's going to equal one of those two things. Well, which one is it? First off, our domain is all real numbers because you can plug in anything you want for x. Who cares? There's no restriction for x here. But which one is it a positive or negative? Question in the chat. No, of course. No. You can't log negative numbers. That's what I said. We can't log negative numbers. Y could equal a negative. No, they could have a negative. Y could equal negative 4 times. Why not? That's fine. You have a negative coefficient. I think what I said was you can't. I might be confused. Maybe I need to ask the person who asked the question what they meant by that. But you can't log negative numbers. But sure, y equals 4ex or 4e or negative 4x, but we have to choose which one. I'm going to go with this one because y must equal negative 4 when x equals 0. So if I plug in 0 for x, y will equal negative 4, and that's going to be your answer. You have to be mindful about when you have when you have absolute of y and then it equals positive or negative, you got to figure out which one it's going to be. And that's just use your initial value for that. The domain's all real numbers because there's no restrictions for x here. X is an exponent, who cares? You can do whatever you want. But again, separate, integrate, substitute, isolate. It's 4 steps. Yeah, I'll recap it one more time. So remember, I isolated. I divide both sides by y, then went over here. Multiply both sides by dx, and went over there. That's kind of all the practice in the previous page. That was separating. Then I integrated. The integral of 1 over y is natural log of y. The integral of 3x squared is 3x cubed over 3, and there's a plus c. So I integrated. Then I had to I had to substitute, so I put in -4 for y and 0 for x. C equals natural log of 4. Done that correctly. So now my equation is natural log of absolute of y equals x cubed plus ln 4. This is where it gets a little messy with the algebra. Ln log base e. So absolute of y would be e raised to of x cubed plus ln 4 power. You can actually break apart this power by doing ex cubed times e ln 4, because if you had ex cubed times e ln 4, you could bring it back to ex cubed plus ln 4 by adding the exponents when they have the same base, right? When powers have the same base, you could add the exponents when their powers are being multiplied. But of course, in decomposing it, e ln 4 is actually 4. The reason why that's 4 is because whenever, and it's hard to read now because I cross things off, but whenever you have, like for example, what if I had like 2 times log base 2 of 8? Log base 2 of 8 is 3. So then I have 2 cubed, which is 8. So essentially when the base and the logs are the same and the log is in the exponent space, they cancel out and you just get whatever number you see there. That's why I got a 4 there. And because absolute value, y either equals positive 4ex cubed or negative 4ex cubed. Which one is it? Use your initial value to determine. When I plug in 0 for x, y is should be -4. So I'm going to go with -4ex cubed. And of course, now I've isolated y. So that's how that one's done. Let's try this one more time, then you guys can do a bit of practice. Okay, example 4. Okay. So again, let's separate. So we'll have dy over y equals 2 over x times dx. So remember, we want to get the y's together and the x's together. That's your first step. Next step is to integrate. So I got to do the integral. Let's do this carefully. 1 over y dy. And it's 2 over x. I'll put the 2 off to the side here. 1 over x dx. Well, that's not so bad, because when I integrate correctly, I do get natural log of y, absolute value of y, mind you, equals 2 times natural log of absolute of x plus c. Okay. Now, in case, and actually, we'll just leave it like that for now. We won't, then we'll substitute. So you have -2, 4. So I have natural log of 4 equals 2 times natural log of absolute -2 plus c. And so it would be natural log of 4 equals 2 times natural log 2. You can get rid of the absolute value after you work it out. Now, in case you guys forgot, there's a property of logs. When you have something being multiplied, you can move it to the back as an exponent. That's the power property of logs. Going back all the way to algebra 2. So it's natural log of 2 squared plus c, or natural log of 4. So c is just going to be 0. So your constant is 0. Okay, so hopefully we're okay with everything so far. So again, put the y next to dy, put the dx next to 2 over x, integrated. So now what do I get? Well, I have this. We'll do some black. I have natural log of y equals 2 times the natural log of x. Or I could say natural log of y equals natural log of x squared. Because you can move 2 to the back. And you can lose absolute value because you are squaring x. So you actually really don't need it anymore. Now, let's actually, if you think about it, what does this mean? So this means that the absolute of y equals x squared, because the elements drop off. So again, we're doing the isolate part here right now. Don't worry, I'll answer part A, the equation of the tangent line, but I just wanted to solve this first. So y either equals positive x squared or negative x squared. But because when I plug in -2 for x, I get +4, not -4. I'm going to go with this one. Now, y could have equaled negative x squared, and that's okay because you're doing absolute value of it anyway. But given the initial condition, you have to go with positive x squared, because when x is -2, y is 4. Okay. Now that I've done all that, let's actually, so actually I've done part B for you, come to think of it. I should have actually held off on that, but that's okay. So I've actually done part B. This is all part B, because that's what part B is asking for. You have to state the domain. Now, the thing is that given the differential equation here, you are going to have 2 branches. Either x is between -infinity and 0, or between 0 and infinity. Even though we get y equals x squared as our solution, the differential equation is not defined at x equals 0. So, but because x is -2, you're going to go with this branch instead. So that's going to be your domain. And that's because of the initial differential equation that was given to us. I haven't done part A yet. I've done part B, actually. Someone's asking where's part A. I haven't done part A. This is all part B. Yeah, I didn't read the directions carefully. I just got carried away and started solving differential equations. So this is all part B. Part B was asking to solve the differential equation. Part A is asking something different. And I'll get to part A in a little bit. But this is all part B. Okay. Any questions of how I solved that? Again, move the y from right to left, move the dx from left to right, integrate both sides. Remember, we have 1 over y is natural log of y, 1 over x natural log of x. There's a 2 being connected now to natural log of x. There's a plus c. Plug in my initial condition, -2 for x, 4 for y. When I solve for c and using some log properties, 2 times natural log of 2 actually becomes natural log of 4. So 2 rolls to the back, and the 2 is in front of the log, rolls to the back. And this, then c just 0. So your equation in black is natural log of y equals 2 times natural log of x. Again, roll that 2 back. Natural log of y equals natural log of x squared. The logs drop off. And then you have 2 possibilities, y equals x or y equals negative x squared. Which one is it? Well, it's going to be y equals positive x squared because we want y to be 4 when x is negative 2. If y is negative 4 and x is negative 2, now we've gone with negative x squared. And then you had to recognize the fact that, well, in the differential equation, x cannot equal 0. So yes, naturally, it looks like you could plug in 0 into y equals x squared, but because it couldn't be substituted into this part, you actually do have two branches. From negative infinity to 0, 0 to infinity, because 0 is undefined for the differential equation. Which one you're going to go with? You're going to go with the left branch because x is negative 2. Now let's talk about part A. For part A, they're asking to find the equation of the tangent line. Remember, the equation of a tangent line, really easy. It's just this, right? Just use point slope form. And remember, m is your derivative, right? So m equals dy over dx at negative 2 comma 4. So let's just work that out. That's just 2 times 4 over negative 2, which is negative 4. So that's your slope. So negative 4, and your x value is negative 2, so x minus negative 2, and y minus 4. And the negative minus negative 2 becomes like that. There you go. So that's that one. Okay, so I'll definitely do videos on examples 5 and 6. Sorry, pages 5. Well, yeah, examples 5 and 6, which is on page 5, and then example 7, and then examples 8 and 9. So I'll do a video on all that stuff. I know class is over in about 10 minutes or so. Let me just pull up the worksheet, maybe have you guys kind of work on your own, that we can share answers at the end. So we'll just for a few minutes. Let me stop the recording.